In this video, we're going to go through a basic overview of vectors. We're basically going to talk about the mathematical part of vectors. Now, a Cartesian plane is majorly used to represent vectors. So this part majorly represents the first vector, which is the unit vector I. Now on this side, we're going to have the unit vector j. This is going to be the unit vector k. Now unit vectors could be represented this way, with a caret or a cap on top of it, basically. Now you could have various units of the unit vector. So you could have some x amounts of the unit vector, you could have a y amount of it, you could have a z amount of it. So typically a real representation for a major vector is going to be a, and that will be equal to I, well, that should be x multiplied by I, plus y multiplied by j, plus z multiplied by k. Now we know that these are the unit vectors, so you could well write that there, or you could well just leave it. But this is the basic representation for vectors. So if we got x, let us say x is equal to 3, let's say y, if you got y equal to minus 2, and z, let's say that is equal to minus a 4, and this is going to be a. Now a, that is going to be equal to 3i, and here we're going to have a negative 2, so that will be a minus 2j. You need to rewrite that, minus 2j. Now k, that will be a minus 4k. So this is one type of vector I could have. Let's say a is equal to 3i minus a 2j minus a 4k. Now let us say you got another vector b. And let's say this is I plus a 2j plus a 3k. So these are typically two type of vectors that I could actually represent or write out from the basic form. Now what if you were asked to find vector A plus vector B? How would you do it? So basically that is going to be 3i minus 2j minus a 4k, and we're going to have an I here. This is going to be 2j, and here we're going to have a 3k. So we basically just need to add it in this way. So this is going to be negative 4k plus 3k. Now negative 4k plus 3k, that is going to be a negative k. Here we have a negative 2j plus a 2j, so that will be 0. That is going to be a 0j. Now this stuff multiplied by this, that is going to, well, that should be added rather. So this is going to be 4i. That means from this place, vector A plus a vector B, that is equal to 4i minus a k. Now what if we had a minus a b? What is that going to give us? So this is going to be 3i minus 2j minus a 4k. And here we got I plus 2j plus 3k. So we got negative 4k minus 3k. So that will give us a minus 7k. Here we're going to have a negative 2j minus 2j, because you're going to have a negative multiplied by positive, which should basically end up producing a negative. So we have a negative 2 minus a 2. That will give us a minus 4j. Now here we have a 3i minus an I. So that is going to be 2i. So in that case, you can see that vector A minus vector B, that is equal to 2i minus 4j minus 7k. So hopefully you understand how to add or subtract vectors now. Now, if you had a unit vector I and that were squared, what is going to be the answer? Now, the answer to this is going to be a 1. What does that mean? That means I squared is going to be equal to I dot I. This is called as a dot product, and this is basically going to give a 1. That goes for the same case as j. The unit vector j squared is going to be 1, as well as k. K squared is also going to be a 1. Now, what if I took I and multiplied it with a j? What is that going to give? Well, so before I do that, I'm just going to wipe this out. Let us begin with this one. I cross I. This is the cross product. So this is going to give us 0. Now, j cross a j, that would also be 0. And k cross k, that is also going to be 0. Now, how about I cross a j? What is that going to give? This will give a k. If you got a j cross a k, that is going to give you an I. And if you got a k cross an I, that will give you a j. So you just need to hold these nuggets at the back. They would really come in handy as you solve some questions later on. Now let us try to find out what is going to be the dot product between these two vectors. So that is going to be a dot b. If you want to find out the dot product, there's two formulas. Now first you could take the absolute form of the two vectors, or the magnitude, or the modulus. That will be multiplied by cosine theta, where theta is the angle between the two vectors. So if you worked this stuff, this would give you the answer to the dot product between two vectors. And it happens to be that we do not really have the angle between the two vectors. So what we're going to do is just use this method. So we're just going to work it straight on using a dot b. So if you want to work it that way, you're going to have a 3i minus 2j minus a 4k. This will be multiplied by I plus a 2j plus a 3k. So first thing you need to do, we need to take this and multiply it with this. Now 3i multiplied by I, that is going to give us 3i squared in it. Now this is going to be added to negative 2j multiplied by positive 2j. So that will give us a negative 4j squared. On this side, we're going to have a negative 4k multiplied by positive 3k. So that will be a negative 12k squared. Now we already know that I squared, j squared, as well as a k squared, they're all going to yield a 1. So we should have a 3 multiplied by a 1 there, which basically reduces to a 3. And we're going to have a negative 4. Here we're going to have a negative 12. So this is 3 minus 4, which gives us a negative 1, minus a 12. So that is going to be minus 13. Therefore, the dot product between the two vectors a and b, those are 13. Now what if you were required to find the angle between the two vectors? So we know first of all that the dot product between the two vectors, that is equal to 13. Well, that should be a negative 13. Now we know that the formula for the dot product, that is going to be a dot b is equal to the absolute form of a multiplied by the absolute form of the vector b, and that should be multiplied by the cosine of theta. So we need to find what is going to be theta. Theta will be the angle between the two vectors. So I need to get these ones first of all. So what is going to be absolute A? Absolute A is going to be the modulus or the magnitude of the vector A. How can we find it? So basically we need to take the coefficients of the first vector A and square them and have them all grouped under the square root. So for this one, this is going to be a 3 squared. On this side we have a negative 2 squared. So this is going to be plus minus 2 squared. On this side we're going to have a minus 4 squared. This is going to give us a 9. This gives us a 4. This is going to give us a 16. Now 4 plus 16, that is going to give us a 20. So we got a 29. This is going to be 9 plus 20, which gives us root 29. Therefore, the absolute form of the vector A is going to be equal to root 29. Now let us find out what is going to be the absolute form of the vector B. The absolute value for the vector B. So this is going to be 1 squared. Here we're going to have a plus 2 squared. Here we're going to have a plus 3 squared. Now this is going to give us a 1. This will give us a 4. So this will be plus 4. And this gives us a 9. Now 1 plus 4, that is a 5. Now 5 plus 9, that is going to give us a 14. So this is root 14. So that is going to give us root 14. So as usual, we know that the dot product between the vector A and the vector B, that is going to be the absolute value for the vector A multiplied by the absolute value for the vector B multiplied by cosine theta. So cosine theta, that is going to be equal to A dot B. And that will be divided by A multiplied by B. This time we have already gotten it to be minus 13. Now these two ones, we have it to be root 29 multiplied by root 14. So let us find what that is going to give. So that is minus 13 divided by root 29 multiplied by root 14. So that gives us 0.645. So this is a negative 0.645. So we got cosine theta is equal to negative 0.645. So in order to get this, we need to take the inverse of this, which is going to be called as the arc cosine. So that is going to be cosine to the negative 1. And here we're going to have a 0.6. Now I need to write this as a minus 0.645. So this gives us 130.2. That is approximately. So this is going to be the angle between the two vectors, 130.2 degrees. So that will be basically it. Now what if you were required to find out what is going to be the cross product between these two vectors? How would you solve it? Now the cross product for the vector A as well as the vector B is represented this way. And there is a formula for it. That is going to be the absolute value for the vector A multiplied by the absolute value for the vector B. And that will be multiplied by sine theta. Now, as usual, we do not know. Well, in this case, we do actually know what it is, but I just want to show it in the other way. Now that we know the absolute value for A is root 29 and the absolute value for B, that is root 14, we need to find out what is going to be sine 130.2. That is going to give you exactly the same answer as what you're going to have on the left hand side. But I just want to teach you stuff which you need to do on the left hand side. Now, just hold this one at the back. So I'm just going to take this one out for now. So typically stuff should be this way. This is going to be I. We're going to write a G there. There is going to be a K. So we need to take the coefficients of the first vector and place it within this row. So that is going to be 3. Here we're going to have a minus 2. Here is going to be a negative 4. On this side we're going to have a 1. This is going to be a 2. This is going to be a 3. So we need to place a plus, a minus, and another plus at the top of the vectors. So we need to take this one out. That is going to be plus I. And cross out the entries in the same row with it, as well as the entries in the same column with it. That is going to leave us with this set of numbers. So we need to find the determinant for these numbers. That will be negative 2 multiplied by 3. That gives us a negative 6. And immediately you do that, you need to write a negative immediately after. Then find what is going to be the product between these two diagonal numbers. This is 2 multiplied by negative 4. That is a negative 8. So you got to write a negative 8 there. Next up, we have a negative j. So we need to take these ones out as well as these ones. So we should have a 3 multiplied by 3. That will give us a 9. And immediately after that, there is a minus. Next up, we're going to have a 1 multiplied by negative 4. That should give us a minus 4. Next up, we have k. That will be plus k. So if I took this one and took this one out, we're going to have this set of numbers. So 3 multiplied by 2, what is that going to give? That will give us a 6. Now that will be 6 minus 1 multiplied by negative 2. That is going to give us a minus 2. Now, if you got a negative 6 plus an 8, from here we can see that this has got to be a plus, because this is going to be a negative multiplied by another negative. So that gives you a positive. So this is going to be minus 8 plus, well, minus 6 rather, plus an 8. That will give us a plus 2. So we got plus I multiplied by plus 2. And here we got 9 plus 4. That is going to be plus 13. On this side we got a plus k. This is 6 plus 2, which gives us an 8. So this will be 2i. Here we're going to have a minus 13j. On this side we're going to have a plus 8. So that will be plus 8k. Therefore, the cross product between the vectors a and b, that is going to be equal to 2i minus 13j plus 8k. That will be the answer for that. Now let us say that you are required to find out what is going to be the unit vector in the direction of the vector b. Now the unit vector in the direction of the vector b, that should be written this way. That is going to be the vector b divided by the absolute form of that vector. We already know what is the absolute value for the vector b. That was given as root 14 in it. So the unit vector of the vector b in the direction of that vector, that will be 1 divided by the square root of a 14. And we're going to multiply with the vector b, which is this. So that is going to be I plus 2j plus a 3k. So this is basically going to be the answer to it. Now finally we want to try out something. if you were given two vectors, vector A, well, let us say you were given another vector C, and that was equal to 2i minus 3j plus a 5k, and you were required to find out what is going to be the direction cosine of A cross B cross a C. What is that going to be? Find out what will be the direction cosines of this vector. So you need to understand that this is going to be a whole vector altogether. But we need to work it gradually. So first we need to work what B cross C is. And later find out what is going to be A cross of the vector B cross C. So first let us find B cross C. So this is going to be I. We got a J under K. So this is going to be a plus, this is a minus, this is a plus. Now we need to write out what will be the values of the coefficients of the vector B, which is 1 for I, and we got 2. Here we got a positive 3. Now for C, we got 2 minus a 3, and here we got a 5. So as usual, we need to take out a plus I, and take out these ones, and that will leave us with these. So 2 multiplied by 5, that is going to give us a 10. So we need to subtract with whichever answer we're going to get in the second diagonal multiplication, which is negative 3 multiplied by 3. That is a minus 9. Now this is going to be minus j. And as we take these ones out, we're going to have a 1, 2, 3, and a 5. So 1 multiplied by 5, that is going to give us a 5. And we got minus 2 multiplied by 3. That is going to give us a 6. Next up, we got a plus k. Now, as we take these ones out, we got a negative 3. So this will be minus 3. And we have a 2 multiplied by 2. That is going to give us a 4. So we got to have a minus 4 right there. So B cross C, that is going to be I multiplied by 10 plus 9. This is going to give us a 19. On this side, we're going to have a minus j. This is going to give us a minus 1. On this side, I got a plus k. And this is going to give us a minus 7. So this, I think I need to write it here. B cross C is going to be equal to 19i minus, well, this should be a plus. We got a negative j multiplied by negative 1. So that gives us a positive j. On this side, we have a minus 7k. Next up, we got to take a and have it multiply with that. So that is now going to look like this. So we got I, this is a j, this is a k. So we got plus, minus, and the plus on top. And here for a, that is a 3, negative 2, and a negative 4. And here we got a 19, this is a 1, and this is a minus 7. So I think I can take this one out. Now here we should have a plus I. So this one goes out as well as this. So we're going to have these one. Minus 2 multiplied by minus 7. That is going to give us a positive 14. Now we got minus 1 multiplied by minus 4. That is going to give us a minus 4. And here we're going to have a negative j. So this is a negative j. As we take these ones out, we're basically going to have a 3 multiplied by negative 7. That is going to give us a minus 21. Now here we got minus 19 multiplied by negative 4. What is that going to give us? So first we're going to have a negative 40 minus a 36. So this should give us a 76. So that is a minus 76. Next up, we got a k. So that will be plus k. Now, as we take this, we're going to have this stuff left. So this will be 3 multiplied by 1. And that gives us a 3. On this side, we have a minus 19 multiplied by negative 2. That will give us a minus 38. So vector A cross vector B cross vector C, that will be equal to plus I multiplied by 14 plus a 4. Now that should give us an 18 minus J multiplied by negative 21 minus 76. That is going to give us 97 minus 97. For J, for K rather, that will be 3 plus 38. That will be 41. So the answer here is 18I plus 97J plus a 41K. Now we're not really yet done, because what was required of us is to find out what is going to be the direction cosines of this product. So how are we going to do it? Now first, you need to understand that the cosine, or the direction cosines rather, are written as cos alpha, and the first one is going to be x divided by the absolute form of the vector. So we'll really need to find out what is going to be the absolute form of this. And for the second one, that is going to be cos beta. That will be y. That is the second coefficient of the y unit vector, which from here you can see that is a 97. This is basically going to be the same thing. We got a cross b cross a c. And you're going to have it for the last one. So that is cos gamma, and that is going to be equal to z divided by the same thing. So this is a cross a b cross a c. So this is all bracketed. So this is basically it. So first we need to find out what is going to be the modulus, or the magnitude of this. So the magnitude of this that is going to be equal to this. So we got 18 squared plus 97 squared, and this is going to be plus 41 squared. So what is that going to give us? So let's find that. So that is going to be 18 squared plus a 97 squared plus a 41 squared, and this is going to give us 106.84. So this is 106.84. That will be the absolute form. So we need to find out all the others now. So everything from hence should actually come off easy. If we want to find cosine alpha, that is the first direction cosine. So we needed to find out what is x. Now, as you well know, so I'm just going to take this stuff back. We got x, so I need to write it there. X is equal to 18. Y, that is equal to 97. And z, that is equal to 41. So I can take these out now. So cos alpha, that is going to be x divided by the absolute form. Now we know x, that is 18. And the absolute form is 106.84. That is going to be the answer for the first one. Now for the second cos beta, that is going to be y, which we know that is a 97. That will be divided by 106.84. And the last one, that is cos gamma. That will be equal to z, which is a 41, divided by 106.84. So this is basically it. So with this, we have come to the end of this video. Hopefully you have a good understanding of the beginning part of vectors by now. Do have a nice day.